Hello, hi everyone. Welcome to the Student the Brand. This is your Swa sir. Today we are going to discuss about light reflection and diffraction chapter. Light reflection and diffraction chapter. Light, light reflection and refraction chapter. Refraction. Okay, so light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay, so here you can observe when you are considering incident ray, after reflection, light ray will move the same direction. Okay, so here light is a form of energy which gives the sensation of sight. So here you can observe I am taking the incident ray. So this is the plane surface. Plane surface I am taking. Highly polished smooth surface. Highly polished smooth surface. Okay, and incident ray, reflected ray, and normal line. Incident ray, reflected ray, and normal line. Incident ray, reflected ray, and normal line. And so 1 minute. Yes. So here you can see. So I'm taking the plane surface. This is the plane mirror. Plane mirror I'm taking. Right. So this is the incident ray. Incident ray. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is reflecting back is called reflected ray. The light which is perpendicular to the plane surface is called normal line. And here you can observe. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Okay, so the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the light which is undeviated, the light ray which is undeviated, normally if the light ray moves in a homogeneous medium, it moves in a straight line path. If light ray moves in a homogeneous medium, it moves in a straight line path. So without deviating, okay, it moves in a straight line path. That is called rectilinear motion. Okay, so properties of light, rectilinear propagation of light. Light moves in a straight line path in homogeneous medium, means particle exhibit similar properties. That is called homogeneous medium. Here you can observe light moves like this. Okay, incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And the angle between reflected and undeviated line is called angle of deviation. Angle between incident ray and reflected ray, angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. Okay, so this is about reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, now here you can observe. So this is a linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. Right? Now we can take this linear angle. Angle of incidence plus angle of reflection plus angle of deviation. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees, because linear angle is 180 degrees. So we can take loss of reflection, loss of reflection. From loss of reflection, angle of incident is equal to angle of reflection. Point number one. First, point number one, angle of incidence is equal to angle of reflection. Point number two, angle of incident is equal to angle of reflection. Or we can take incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane, and angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. Same formula only, but so we are writing in the second one. So angle of reflection. Incident ray, reflected ray, normal line, then only we can get the angle of incident is equal to angle of reflection, right? Yes. So that's why incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incidence, and the angle between reflected ray and normal line is called angle of reflection, and the angle between reflected ray and undeviated line is called angle of deviation. Linear angle is 180 degrees, so that angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection, we can take incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So from that, so we can take angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So now angle of deviation equal to 180 minus 2 angle of incidence, and 180 minus angle 2 angle of reflection also we can take. So 2 angle of reflection. So angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of reflection. So why you are taking like that? Because from loss of reflection, we know that angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So by that, We can take so instead of angle of reflection, so I substituted angle of incidence. So that's why we got the answer angle of deviation equal to 180 minus 2 angle of incidence. Instead of angle of incidence, if you substitute angle of reflection, so the angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear to you all, right? So this is about reflection of light and deviation angle formula, and one more thing, loss of reflection. So this is about loss of reflection, angle of deviation, and reflection of light. Okay, done. So next one I will discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. So what is regular reflection and what is irregular reflection? Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. So you're taking this. This is the plane mirror. So I'm taking the plane mirror. So incident light rays. So here ray of light, a single ray, beam of light rays. So number of light rays moving together. So based on the convergent, if the light rays converging together, that is called so okay, done. So here you can observe I'm checking. Okay, incident light rays. I'm considering incident light rays. These are the incident light rays. Those incident light rays are parallel to each other. Incident light rays are parallel to each other. Then after reflection, incident light rays are parallel to each other. After reflection, if reflector light rays are also parallel to each other, if reflector light rays are also parallel to each other, so this type of reflection is called regular reflection. So here you can observe I'm taking like this. I'm considering this reflector light rays. Reflector light rays are also parallel to each other. Incident light rays are parallel to each other. Then after reflection, reflector light rays are also parallel to each other. This type of reflection is called regular reflection. This type of reflection is called regular reflection. So coming to irregular reflection, irregular reflection, irregular reflection. So I'm taking a rough surface. Here it is the plane surface. Regular reflection takes place on smooth surface and still water. Regular reflection takes place on smooth surface and still water. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Best example, you can take wall, and paper also, paper. Okay, so these are the term. So where we'll get the irregular reflection, irregular reflection. So here you can see, you can observe here carefully. If you observe here, incident light rays are parallel to each other. Incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Incident light rays are only parallel to each other. Reflector light rays will move in different directions. They'll move in different directions. So in different directions, okay. So this will move. This reflector light rays will not be parallel to each other. Only incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection. So here you can observe regular reflection and irregular reflection. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. And in regular reflection, incident light rays are parallel as well as reflector light rays are also parallel to each other. But here in irregular reflection, only incident light rays are parallel, but reflector light rays are not parallel to each other. So this is about regular reflection and irregular reflection. Now we will discuss about object and image. Object and image. Object and image. So now we will discuss about object and image. Okay. Here you can observe. I am taking the plane mirror. So this is the plane mirror. I am taking the plane mirror. Okay. So point object. This is the point object. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So here, this I am taking the real object, the 2-point object. Okay, still I have to take 2 light rays. So I am taking 2 light rays. So after extended, okay, so if you extend the reflector light rays, if you extend this reflector light rays, so okay, so I'm extending this reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That image is called virtual image. That image is called virtual image. Once again, listen here carefully. Observe here seriously. Here, real object. So from this point, I am considering 2 light rays. I am taking 2 light rays. After reflection, we are extending the reflector light rays. Okay, we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. That image is called virtual image. That image is called virtual image. So I hope it is very clear to all. That image is called virtual image. Virtual image. So I'm taking here, this is a plane mirror. Okay, I'm considering the plane mirror. How many light rays are required? So minimum 2 light rays are required. So after reflection, so here you can observe one thing. This is a real image. Real image. There you can observe virtual image. Sir, what is the difference between a real image and virtual image? So here directly reflector light rays are meeting your virtual object. Here directly reflector light rays are meeting. These are the reflector light rays. 1, 2, these are the reflector light rays. Directly these reflector light rays are meeting, right? So that is called real image. Here extended reflector light rays. We are extending. We are extended. Okay. So these are the reflector light rays. We are extended. Okay. We extended this reflector light rays. Those extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. That is a virtual image. Okay. Then here you can observe directly reflector light rays are meeting. That image is called real image. Directly reflector light rays are meeting. Here we are extending the incident light rays. Extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their virtual object is virtual object. So by observing these two diagrams, okay, so by observing these two diagrams, we can conclude that so object is real, image is virtual. Object is virtual, image is real. I hope you can understand one thing once again. So listen carefully. Object is real, image is virtual. Object is virtual, image is real. Okay, check once. One check. So we'll go to the Okay, so I hope it is very clear. Next, we'll go to the nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror we'll discuss. Nature of the image formed by the plane mirror. So now you can see here. So I'm taking the plane mirror. Object AB. So as I said, for drawing image, for getting image, we need two incident light rays. Okay. So I'm taking two light rays. One light ray I'm taking here. Another light ray lying like this, and here one more. Yes. So from here this point two light rays, and from this point two light rays. Okay. So if the light ray is passing along the normal line, if the light ray is passing along the normal line, it reaches its original path. If the light ray is passing along the normal line or moving along the normal line, it retraces and it moves in the same direction. Okay. So here also same thing I am taking here, and now you can observe here. So I am taking the dotted lines. You can observe here. So A dash and B dash, A dash and B dash. Okay. A dash and B dash. So here object is real, image is virtual. Object is real, image is virtual. Point number one. Object is real, image is virtual. Second point, object is virtual, image is real. Second point is the distance. So this is the object, and the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Once again, the distance between object to mirror is called object distance. The distance between image to mirror is called image distance. So in plane mirror, object distance is equal to image distance, and also height of the image. So this is height of the object and height of the image. Height of the object is equal to height of the image. And fourth one, the magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And last one, fifth one is, it also shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Okay. So lateral inversion. So once again you can observe the ambulance. So the letters written on the ambulance will be in the reverse order, like a mirror image. When you if you stand in front of the mirror, and you lift your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. So the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. So this is about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So this is about plane mirror. Now we will discuss about spherical mirrors. The mirror which is in the form of curved shape, those are called a spherical mirror. So the mirror which are in the form of curved shape. The mirror which in the form of curved shape is called a spherical mirror. Okay, so here you can take. I'm taking. So here you can take the mirror which in the form of curved shape here. Based on a reflection of light, mirrors are divided into two types: concave mirror and convex mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. So here you can observe concave mirror. Concave mirror is also known as converging. Sir, why you're saying, how you're saying, what is the reason behind that? Concave mirror is also called converging mirror, and whereas convex mirror is also called diverging mirror. What is the reason? So, what is your strong point to comment on this? So, what is your strong point? How you're saying? What is the reason behind this? You're saying, you're stressing, you're mentioning, you're mentioning. Okay. So concave mirror is also known as converging mirror and convex mirror is also known as diverging mirror. So the strong reason is when the light rays incident on it, after reflection, you can observe very carefully. After reflection, light rays are moving towards the principal axis. Okay, light rays are moving towards the principal axis. Coming to the convex mirror is also known as diverging mirror. Sir, why you're saying, how you're saying, as I said, what is your strong point to comment on this? So, convex mirror is also known as diverging mirror because whenever light rays falls on it, so I'm taking light rays here. These light rays, after reflection, those light rays are moving away from it. So in concave mirror, after reflection, light rays are converging, coming closer. Whereas convex mirror, so this is a concave mirror, and this one is convex mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Concave mirror, converging mirror. So why you are saying concave mirror is also known as converging mirror means whenever light rays falls on it, converging. Whereas convex mirror, after reflection, those light rays are moving away from it. Okay, so concave mirror and convex mirror. Now we will discuss about ray rules. Of concave mirror and convex mirror, and after that, actually sign conventions are very important. Sign conventions and image formations. After that, ray rules. First ray rules. After that, image formations. After the sign conventions. While doing problems, sign conventions plays very crucial role. Okay, so you have to understand each and every point thoroughly, then only you can able to do the problems. Okay, so that is about sign conventions. So I'm talking about sign conventions, right? And here ray rules we need to discuss, and image formations I'll explain. After that, sign conventions and mirror formula and magnification. So these are the points. Daily I will be taking classes based on CBSE grade 10 physics. At the same time, grade 11 and grade 12 also I'm going to continue. Going to take the classes. So in this channel itself, and you can observe, you can follow the community post. So I'm posting the community I'm posting in the community post. So like important message and instructions regarding the classes and MCQs also. MCQs MCQs are main. Okay, it's in the community post. So I'll be posting MCQs. After that, if any information, if any important announcement need to be announced, so you can check in the community post, right? So thank you so much for joining and attending and listening my class and giving an opportunity to teach the class. So thank you so much to everyone. Please do like, share, and subscribe to Student the Brand. Definitely you'll get good content, great content, and so it will be helpful to your board exams. Okay, and all those questions and grade 11, grade 12, I'm going to start those chapters also soon. Already started few chapters in 11th grade and 12th grade also. Current electricity is started, already explained also, one chapter completed. And grade 11 now, so I explain you units and measurements and motion in a straight line and motion in a plane. Okay, like a projectile motion topic I explained, you can check the videos. Okay, so thank you so much for joining and attending. Please do like, share, and subscribe to Student the Brand. If you like the content, if you like the explanation, if you like the channel, you can inform your friends, ask your friends to join to the class. So thank you so much. This is our sir. See you.